Hello everybody, welcome into another lesson. So today we are going to talk about parametric equations. So here you see an example of parametric equations. You have x equals 2t minus 2 and y equals negative 2t plus 3, for 0 is less than or equal to t, which is less than or equal to 5. So in a parametric equation, your x and your y variables are both dependent variables that are dependent on the parameter t. The t is called your parameter. And classic examples of a parameter are time. Usually that t denotes time. That's your biggest parameter. This is the change in the x position and in the change in the y position with respect to time. And we're going to graph these at first. So it tells us the domain of t is from 0 to 5, inclusive on each. So to find your coordinates and graph this, let's put in 0 for t. So that means x would literally equal negative 2, and then y would equal positive 3. So when t is 0, you got x is negative 2 and then y is 3. And then next we'll put in 1 for t. So if t equals 1, that means we'll end up getting x equals 2 minus 2, which is 0. And then y would equal negative 1 plus 3, which would equal positive 2. So you would have your x coordinate at 0, y would equal positive 2. So that'd be right there. And then we'll do a few more of this. So let's take this now when t equals 2. So this would end up becoming 4, let me specify what variable we're finding. So if we put in 2 for t, you would end up getting x equals 4 minus 2, which equals 2. And then for y, you would end up getting negative 2 plus 3 equals 1. So you would have the coordinate 2, 1, which is right here. Now let's do when t equals 3. So if t equals 3, that means you would end up getting x equals 6 minus 2, which would give you 4. And then y would equal negative 3 plus 3, which means y would equal 0. So you would have the coordinate 4, 0. And then we can do when t is 4. So if t is 4, that's going to then give us for x, that would equal 8 minus 2, which means x would equal 6. And then for y, you would get negative 4 plus 3, which means y would equal negative 1. So you would have the coordinate 6, negative 1. And then we can do when t equals 5. So let's see, t equals 5, so that would give you x would equal 10 minus 2, which would mean x is 8. Y would equal negative 5 plus 3, which means y would equal negative 2. So you'd have the coordinate 8, negative 2. And now we can go ahead and graph this. And it definitely is a line. You get a line here. So you can produce graphs of lines and other things with parametric equations because both your x and your y position are changing with respect to that parameter t. And of course, to get your coordinates, you have to consider both coordinates, x and y. And I got more of these. Okay, let's see. This time, again, we'll do 0 is less than or equal to t, which is less than or equal to 5. So for x, you would have that equal to 5t minus 5. Y would be equal to 3t minus 2. Okay, so we're going to graph this again, and the parameter t has a domain from 0 to 5. Now, we probably don't have to do all 5 points. I was just doing that to draw a nice smooth graph. You can do as many points as you want in between, but bare minimum you need 2 points, at least the beginning and the end. So, let's see, what about when t is 0? If we put in 0 for t, we would get x equals 0 minus 5, which would give you x at negative 5. And then for y, you would end up getting 0 minus 2, which would give you y as negative 2. Now this is going to get real big here, so I'm going to say we make one of these count for 2 units on each axis. So negative 5, negative 2 would be down here. And then what about when t is 5? Let's do when t is 5. So you at least need the 2 endpoints. It couldn't hurt to do more points, but let's do when t is 5. So that would give you x equals 25 minus 5, which would give you x equals 20. And then y would be, let's see, 15 minus 2, which would be 13. So you would get the coordinate 2013. So that would put you all the way up here if we were to make each of these based on 2. Just trying to draw this straight here. This is why I often choose more points, because there you go. So there you have it. You have another line. There's the graph of this parametric line with changes to both x and y based on your parameter t from 0 to 5. Let's do one more for graphing. So this time we have 3 is less than or equal to t, which is less than or equal to 8. And x changes based on the parameter for t of 2t minus 6. Y changes based on the parameter of t minus 3. Well, good news is we can probably make each unit worth 1, but let's go ahead here. Let's take when t is 3. So when t is 3 for x, you would end up literally getting 6 minus 6, which equals 0. And then for y, you would get 3 minus 3, which is also 0. So you would get the point 0, 0 when you have the parameter of t being 3. Now what about when t is 8? Let's go to the end of our domain. So t equals 8, so x would equal then 16 minus 6, which means x would be 10. And then y would equal, of course, 8 minus 3, which would be 5. So you're going to have the coordinate 10, 5, which would be right there when you have t equals 8. So there's the line graphed by this parametric equation, and it reflects changes in both your x and y units based on that parameter t. And they could be other parameters besides time, but classic examples are like changes in velocity or changes in direction or other things. When you change directions, you're usually accounting for both a left and right and a up and down movement. So that's where the parametrics come in. Okay, so those are graphing parametric equations. Now I'm going to take these down because you can also convert parametric equations into standard xy functions. Alright, so the next goal is convert the parametric equations into an equation of y as a function of x. Find the domain and range. Alright, so we're about to be given some parametric equations here. You can convert them to normal functions of x. You can convert it into an equation of y being a function of x. And then from there you can find the domain and range. So let me write with a different color. So we have x equals 2t and y equals negative 4t for 0 is less than t, which is less than or equal to 5. Alright, so how are we going to do this? Just how do we do that? So we know if we convert this into a y as a function of x, what is true? That x is your domain and y is your range, right? So we can easily find the domain. The domain, you'll just put in your lowest value of t, which it can be. Well, what's 2 times 0? That's going to be 2, right? So your domain will start at 0, then put in that value of 5 for t. 2 times 5 is 10. So your domain will be from 0 to 10 inclusive. That's the value of your x. And then we can find the range just as easily because the range is always your y value, right? Again, put in your lowest value of t. What is 0? Negative 4 times 0, that's 0. And then let's put in 5 for t. Negative 4 times 5 is negative 20. So those parts of the question were answered. You have a domain from 0 to 10 and a range from 0 to negative 20. Now, how do we convert these into one equation where y is a function of x? You have to do something called eliminating the parameter. So take a look at x equals 2t. What you want to do is solve for t. So x equals 2t. That means then that t equals 1/2 of x. T equals 1/2 of x, so then you'll come to your y, where y equals negative 4t, so you'll take y equals negative 4 times that value of t, which was 1/2 x, which would then mean that y would equal negative 2x. So that's what they're looking for. You get y equals negative 2x. And we know this checks out too because when we were graphing these, we were getting equations of lines. And that's an equation of a line. So that is how you convert. And we got more examples here. Keep my step counter going. All right. what if, let's see, we are this time given x equals t plus 1 and y equals 2t minus 3 for, what's the parameter, what's the domain of t? Again, for 0 is less than or equal to t, which is less than or equal to 5. Alright, so we have parametric equations, x equals t plus 1 and y equals 2t minus 3, for the domain of t being 0 is less than or equal to t, which is less than or equal to 5. Well, first let's find the domain. So take the lowest value of your domain of t, which is 0, put that in for x because your domain belongs to x, right? If you put in 0 for t, you'll get 0 plus 1, which would be 1. And then if you put in 5 for t, your highest value, you get 5 plus 1, which is 6. So your domain is going to go from 1 to 6 for your x. Now we can find our range. The range, if you put in 0 for t, you would literally get 0 minus 3, which is negative 3. If you put in 5 for t, you would get 10 minus 3, which is 7. So your range would be from negative 3 to 7. Now, we want to convert these two parametric equations into one equation where y is a function of x. So let's look at x equals t plus 1. Again, you want to eliminate the parameter. So you need to solve for t. So that means t would equal x minus 1. Now you're going to come over to your y equation. Y would equal 2 times that value of t, which in this case is x minus 1, all that minus 3, which means you would get 2x minus 2 minus 3, which means that y would be equal to 2x minus 5. So what you're looking for to get y as a function of x is y would equal 2x minus 5. Alright, what's next? One more for this, and then we're going to do like 3 other types of exercises. So let's see, we have x equals 3t plus 6 and y equals 5t minus 1. This time for 0 is less than or equal to t, which is less than or equal to 20. So the domain of t is from 0 to 20. Well, first let's find the domain of what's going to be the equation of y as a function of x. Again, we know the domain belongs to the x values, which would be your independent variable. So put in your lowest value of t, which is 0. So if you put in 0 for t, you would get 0 plus 6, which is 6. So the lowest part of your domain is 6. Now put in 20 for t, you would get 3 times 20, which is 60 plus 6 is 66. So your domain will go from 6 to 66. Now what about your range? You can find it just as easily by putting in the lowest value for t, which is 0. You would get 0 minus 1, which is negative 1. And then your range, upper limit of that, would be 20 for t. So what's 5 times 20? That's 100. Minus 1 is 99. So you get a range from 6 to 66. A domain from 6 to 66. In a range from negative 1 to 99. Now the last thing we have to do to get y as a function of x is to eliminate the parameter. So take x equals 3t plus 6, you want to solve for t. So that means that 3t would equal x minus 6, which then means that t would equal 1/3 times x minus 6, which we should probably just solve completely for this and do the distribution. So t would equal 1/3 of x minus 2. Alright, so now we got t in terms of x. Let's bring that over here and put it into our y equation. So y would equal 5 times our value of t, which was 1/3 x, minus 2, all that minus 1, which would, when we distribute, would give you 5/3 x minus 10 minus 1. So that means y would be equal to 5/3 x minus 11. That's how you would find an equation for y as a function of x. So y would equal 5/3 x minus 11. Alright, so there's that. Now I got 3 more problems, then we're done. So you can also apply parametric equation to motion problems. So we're going to do 3 equations of linear motion. So we're going to apply this to the real world a little bit. So find parametric equations for the linear motion that is described. Okay. So we're going to have 3 problems here of linear motion problems. So they want us to find for each problem 2 parametric equations for the linear motion that is described. So in this case, you're going to have an object is at 0, 0 at time t equals 0, and then at 1957 at time t equals 3. Alright, so this linear motion talks about an object is at 0, 0 at a time t equals 0. And then at 1957 at time t equals 3. So notice that we have a parameter t, the classic parameter t. This is related to time. And notice between both 0, 0 and 1957 you have changes in both your x and y. So what are we going to do here? Well, we first need to find the slope of each. Let's find the slope of each. So what do I mean by that? To find the parametric equation for x, you have to treat x as the dependent variable and t as your independent variable. So let's see. So the first slope is going to equal your change in x over your change in t, or delta x over delta t. So you go from 0 for your x to 19 for your x, so that means it's going to be x sub 2 minus x sub 1 over t sub 2 minus t sub 1, which in this case would be 19 minus 0 all over, then your t goes from 3 to 0, right? So 19 all over 0, 19 minus 0 all over 3 minus 0. So that means your first slope is going to be then 19/3. And then from there, you should be able to get an equation for your x. You're going to do this much the same way in point slope form. So you would end up taking x minus your x1 would equal your m times your t minus your t1, which can be really simple in this case. This could be x minus 0, because you can make that your x sub 1 equals your slope of 19/3 times t minus your t of 0. So you should literally just get that x equals 19/3. So there's your first 19/3 t, excuse me. So there's your first parametric equation. X would equal 19/3 t. Now we need to do the same for y. Let's find the next slope. So we'll treat y as the dependent variable and t as the independent. So this time your second slope would be delta y over delta t. So that would be y2 minus y1 all over t2 minus t1. So your second y is 57 minus your first y of 0. And then your second t is 3 minus your first t of 0. That's just going to give you 57 over 3, which is 19. So we found the slope of your y line. Now you're going to do much the same. Put this into point slope form. Since y is your dependent variable, you would take y minus y sub 1 equals m times the t minus t sub 1, which in this case you could take y minus 0 equals that slope of 19 times t minus 0, which will literally just give you that y equals 19t. So the two parametric equations you're looking for are x equals 19/3 t and y equals 19t. And I got two more like this. I have two more problems like this. Alright, so Alright, so we have an object is at 18.8 at time t equals 4, and then at 40.8, 19.0 at t equals 9. So, again, first thing you probably want to do then, set up the slope for your x line of the parametric equation. So, let's write in black. So, we could just say m sub x for my slope. Well, that's going to be my change in x over my change in t. So let's see, my second x is 40.8 minus my first x of 18 all over my change in t. So my second t is 9 minus my first t of 4. Well, then that's going to end up giving me 22.8 over 5, which I know I can get this in a simpler way. I would get 4.56. So the slope of my x parametric equation would be 4.56. Now I can take and find my equation by taking x minus my first x, which is 18. So x minus 18 would equal that slope of 4.56 times my t minus my first t of 4. So that means then x minus 18 would equal 4.56 t minus, let's see what 4.56 times 4 is. Minus 18.24. So that means then my parametric equation for x would literally equal 4.56t minus 0.24. So there's my parametric equation for x. X would equal 4.56t minus 0.24. Now let's find the slope of our y line. So m sub y would equal my change in y over my change in t. So let's see, y2 is 19.0 minus my y1 of 8 all over my second t of 9 minus my first t of 4. So this is literally just going to give me 11 over 5, which we know is going to be, let's see, that'd be 2 1/5, so that'd be 2.2. So the slope of my y line is 2.2, so now I can go ahead and find my parametric equation for y. So this is going to be y minus my first y coordinate of 8, then equals my slope of 2.2 times my t minus my first t of 4, which then means that y minus 8 equals 2.2t minus 8.8. So then that means that y would equal 2.2t minus 0.8. So the two parametric equations you should get are x equals 4.56t minus 0.24 and y equals 2.2t minus 0.8. And I got one more, then we're done. Alright, what do they give us this time? Alright, so we have an object is at 3, 2 at time t equals 0, and then at 14.366.1 at time t equals 5. So let's go ahead now, let's find the slope for our x line. So m sub x, that's going to equal my change in x over my change in t, which in this case, my change in x, so my second x coordinate is 14.3 minus my first x coordinate, which is just 3, all over my second t coordinate, which is 5, minus my first t coordinate, which is 0, which would end up then giving me 11.3 over 5, which should simplify relatively shortly here. Into 2.26. So the slope of my x line for the parametric equation is 2.26. Now we can easily find that parametric equation if we take x minus the first x value of 3, set that equal to my slope of 2.26 times the quantity of my t minus my first t of 0, which means x minus 3 would equal 2.26t. So I should literally get from my first parametric equation that x equals 2.26t plus 3. And then I still have to figure out the y equation for the parametric equations. So let's find the slope of the y line. So m sub y, that's going to then equal my change in y over my change in t. Well, my second y is 66.1 minus my first y, which is 2, all over my change in t, so that'd be 5 minus 0. Well, that's literally going to give me 64.1 divided by 5, which then I should be able to get a value of my slope for y. I get 12.82. So the slope of my y line is going to be 12.82. Now I can find that equation easily. For y, I take, let me write in blue for that so we can see where we're at. So if I take y minus my first y of 2, set that equal to my slope for the y line, which is 12.82, times my t minus my first t of 0, I'll end up with y minus 2 equals 12.8t, or simply put y equals 12.82t plus 2. So the parametric equations I should get are x equals 2.26t plus 3 and y equals 12.82t plus 2. Alright, so that's it for this lesson. We only have 5 more lessons left in Algebra 2 Trig, and then we'll be on to Pre-Calc, which at the end of this week, beginning of next, we should be out of Algebra 2 Trig into Pre-Calculus. So the very next lesson is going to be about trigonometric identities, which are absolutely critical for being able to solve trigonometry problems in here, in Pre-Calc, and even in Calculus. So I hope everyone has a great day. Take care.